Good morning, ladies and gentlemen. So today we have one interesting discussion which reads to say the random variable x is known to be uniformly distributed between 1.0 and 1.5. The first question which we have reads to say show the graph of the probability density function. Remember in the previous video I had shown you how the graph of the probability density function is drawn. So we will not much waste of your time. So we will just go directly in drawing the probability density function. So it is easily drawn where you are only concentrating on these two numbers. Remember, like we said, that the probability density function is defined by this expression b minus a, where x is of those limits which are called boundaries elsewhere. So we will explain now why it is 0. Remember in the previous video I left you hanging with so much thirsty to ask why do we put a 0 down here. So when we deal with the probability density function, remember I told you to say the graph is defined with only 2 points called the parameters, and these 2 points form what is referred to as the integral. So you can just estimate where your numbers should be. So like our 1, we not say 1 can somewhere be there, and our 1.5, let's assume it is there. Then what is the height? Remember I told you that the height is defined by 1 over b minus a. This is what the height is defined by. So what is your b? Your b is just 1.5, and what is your a? 1. So when you were to subtract 1.5 minus 1, you get the value to be 0.5. And for you to get the height, you will say 1 divided by 0.5. So 1 divided by 0.5, you get the value to be a 2. So the height of this particular probability density function is a 2. So we have this now to be called the area under the curve. Whereas today we will not use integration, or we will just go directly. You can, if you want, you can use integration. There is no problem. So we know for sure that this is a rectangle, and the area of a rectangle is given by length times breadth. So now that we have known that the area is given by length times breadth, let us solve the down question. So this is how we solve our A. So let us now solve the other remaining questions. So our B is the simplest of all times. So what do I mean? So remember, they want you to compute the probability of x being equal to 1.25. Remember, I told you already that when we are dealing with the continuous probability, but specifically the probability density function, remember I said it is defined by how many points? 2 points. So since it is defined by 2 points, which means it is never defined by a single point. A single point is used when you are assigning individual probabilities, and that is discrete probability. I think now you understand the difference between continuous and discrete. Discrete is basically to two sample spaces, while discrete is only to 1. Continuous to 2, discrete to 1. So the answer for this one is a 0, because they have said if it does not obey this elsewhere, it is a 0. But why are we saying it is a 0? We should know that the probability that x takes on any single individual probability, the value is 0. So what I'm trying to say is the area under the curve, but above the x-axis, where let's assume to say we only have our 1 here. We only have our 1. We know to say this one and this one again. Does this one and this one have a space in between? No, which means there is no width. So if there is no width, let us assume that the breadth is what? 0. And any number multiplied by this will still be 0. I think now we understand better. So we do not assign probabilities under continuous probability. In short, the answer that we will always be getting is a 0. So we have our C now to be compute this. So what we do here now, remember this will create what is referred to as the breadth for us. Remember, this is the length in this case because this side is longer than this one. Yes. So we will just subtract 1.25 minus 1. We get the value to be 0.25. And remember, the length is 2. And we know to say area under the curve is the same as length times breadth. So breadth times the length. So 0.25 times 2, you will get the value to be 0.5. So this is the probability that x is greater than or equal to 1 but less than or equal to 1.25. And we have our D, which is the last question, which is telling us to say we should compute this. So this is done just the same way we have answered C. So if you want, you can pause the video to check if you have understood it more. Try to attempt. Remember to share, like, and subscribe. So let us continue. So we have our 1.5, which we'll subtract with 1.2, and we get the value to be 0.3. If we were to subtract 1.5 minus 1.2, we get the value to be 0.3 multiplied by 2. Remember, 2 is the length, and we will get the value to be 0.6. So this is how well we answer such questions under continuous probability. Let us wait for more questions to be answered in the next videos so that we share some nice ideas. Your host, Golden Zulu.